All right, so sometimes it takes a while. Yeah, there you go. You've started the recording.
Okay, so software testing is one phase in software development that can not be put aside. Like, software testing is required to point out the defects and errors that were made during the development phases. So, well, I'm sure no one wants to fly a plane that has defaults just because some software developer somewhere didn't care about testing. So our speaker today is going to demystify testing Elixir applications for the next 60 minutes, giving us lots of practical ideas we can immediately put to work when you're back in the office on Monday. Born in Nigeria, over 12 years of experience in software development, worked with multinationals that include Mott McDonald, Cambridge Education, Mena Energy, and also founded startups. He has worked on projects used by government and private institutions too. So before I introduce you to him, we will require you to kindly mute your mic and turn off your video to avoid unnecessary interruption during the session. And kindly note that the session will be recorded so as to upload it on YouTube for those who will not be fortunate enough to make it here today. Have you ever wondered why you can't take your eyes off some charismatic public figures while others put you immediately to sleep? Please help me welcome the sensational Shuaib. Shuaib, the floor is yours.
Hi, hello, Podi. Can you hear me?
Yeah, we can.
Oh, nice, good. Hello, guys. How's everyone? Good. Okay. I think our microphones are on like a point. Am I supposed to turn on my camera or just continue with my presentation like this?
Feel free to just turn it on if you're okay with that.
Okay, that could be good. Let me find my way around my. So guys, I think settings, okay, Google Chrome. I'll have to quit Chrome and start all over again, shit. I don't know if I should do this, but let me see how it goes. I probably have to join and start all over again, but so let's just ignore that part of my camera. My face doesn't look that pretty, so maybe there's no point looking at my face anyway. So I'll try to make a presentation of my screen, and I will swap the screen from when I have to write code. Okay, so can you guys see my screen right now?
Yes.
I really would want like communication, right? It seems
yeah, can.
Yeah, it seems I'm alone. Have been in isolation, not isolation, more like staying by myself for a very long time, for like 3 months now. And obviously, because of the coronavirus situation, for most of the time, I we have to work from home. So like, I'm in a foreign country. I'm in the UAE to be specific. I'm in Dubai, and yes, I'm so not used to talking to people. So it feels a little bit empty when I don't get feedback. So that aside, I will be talking about speaking on. I will be speaking on testing Elixir applications. Uh, yeah, I must first of all admit that testing software is a broad field. It requires a lot of effort. It's also a field that has lots of opinions on how testing should go. It's people have different approaches, people have different methods, but the bottom of the thing I, idea is that we have to test our software, right? We have to write tests, and that's what everybody agrees on. Approaches and ways of going about that, it's something that people debate over a period of time. Okay. My name is Shuaib Afegbua. I am from Nigeria, as she has introduced me, Podi. And forget the whole hype. It's just a long time I've been writing software, and for most of it, we learn every day. Uh, from my background, I've been a Java developer for most of my time, and I also picked a couple of programming languages, like we all do as developers. I picked I picked a couple of languages like Scala and Elixir, of course, and Golang and PHP and all that and the rest. So it's always been a fun experience, learning new things and learning new things. So the the first point we want to ask ourselves is what is testing? What testing is all about, right? And we see when we test software, what's the goal? What are we trying to arrive at? For most of it is that we actually test software to ensure the correctness of our software system, right? So we expect our software to behave in a particular way. We have some expected results in all of it. But then we want our software, if we don't create some assertion, some test cases, we cannot actually verify the behavior of how our software works, right? So for most of it, we write tests to ensure that our software is correct, is complete, and is bug-free, okay? The good thing is that I'm of the opinion that there is no such a system that is 100% bug-free. The possibility exists, but the goal for most of the time is to reduce as much bugs as possible and ensure that we achieve the right behavior that we expect from our software system, right? So there is a popular quote in computing by Paul, and it says, to err is human, but to really mess things up, you need, to really foul things up, you need a computer to do that. There have been lots of cases. There have been lots of cases where software that were not tested have led to disaster. In 1990, for example, in 1990, there was a case of the popular telco in the US called AT&T. And AT&T did a software upgrade. And that upgrade was was a hot upgrade to actually make their system work faster, right? It was for their switching system. And there was a bug in the switching system that caused all their switches to restart every time. And the cost of that bug alone amounted to about, let's say, the telcos, they actually deal with costs. Sorry about that. So they deal calls, and they lost about 75 million. They lost about 75 million missed calls. There was about like 200,000 airline reservations that were cancelled. It also cost them about like $60 million in revenue entirely. So this happened just because of on a software bug that probably wasn't covered during the test cases, right? Another situation happened in about, I think, 1999, when the US government sent the Mars orbiter to the atmosphere to actually monitor the atmosphere. And just about 49 seconds thereabout before it was supposed to um, get to its destination, they lost communication with it. And what that led to was the entire launch, the entire probe to the atmosphere cost them about like $374 million to make. Okay, but what was the cause of that bug? What was responsible for the bug? It was just a single line of code. A single line of code where the developer was supposed to use like US customary units. The developer used a US customary units, and instead of using like a custom metric unit for measurement. So the point is that software systems, untested code can be expensive. It can be expensive in terms of cost to the developer, to the company. It can be expensive in terms of time. It can actually kill an entire business and a whole lot of people. So for that, we have to pay attention, like to testing. Okay. So back to the point why we actually test. We test our software because we want to ensure correctness, right? We expect our code, our modules, our functions to behave in a particular way, and we want to make sure they actually give us the correct results, right? We also write tests for regression. So sometimes if we have a break, we like added code, make changes to our code base, we want like our existing code to keep working. So without tests, and you probably have broken some lines of code, some function, some behavior, and then you won't realize that, right? Testing actually help us to plan, right? We write our test cases to plan how we write our code. And it helps us to like easily refactor our code. When we write tests, we can make changes faster, and we can write our components, and we can actually test them, okay? The last reason why I think we have to write tests is that writing tests actually, we also write tests to write fewer tests. And this seems a little bit contradictory, but when you start writing, considering things like property-based testing, when you start doing things like property-based testing, you actually write fewer test cases, and you cover a lot of corner edges within your test. Okay, so for most, testing is quite broad as a subject. Like it's really broad. It's not something you have to cover in 90 minutes or in 1 hour in a day. Like there are a couple of moving parts in test, right? So testing can be functional. When we're testing a software system, we can test like the functional components. We can either test the non-functional components. For most of my talk today, I will focus on the functional components. Let's say functional testing. And in this case, I'll be talking about things like unit testing. I will talk about integration testing if we have much time for that. We'll talk about user acceptance testing, and I'll talk about property-based testing as well. Okay. Yeah, there are other forms of, there are other things that people test in software. It could be things like reliability tests, it could be security tests, it could be like spike testing, it can be like stress and endurance tests, and load testing. All these are forms of testing that happen within when we deal with software systems. Okay, so it's a broad area. I mean, we're an expert in this, but as developers, we just need to write basic tests and to like assert the behavior of how our system works. Okay, so There is a popular test pyramid created by Michael Cohen, where how you should write or structure your test. And its approach is to, you have the unit tests like at the bottom of the pyramid, and they are much in number, they are faster. And we're going to talk about unit tests in a short while. Then you have a service, a bunch of integration tests that form the service test layer, which are a little bit fewer because you're testing across components of the system. And then you have at the top of the pyramid where you have UI test. A couple of people have a disagreement about this. I do as well, but I need to just pull it up. Martin Fowler has a popular article on the test pyramid where he came about a different approach. So regardless of the approach you adopt in testing, the most important thing is that you have to write tests, right? And teams and individuals and developers do decide how to structure their tests and how they should go about handling some of these test cases. So, so let's talk about Elixir as testing. I believe for everybody that is on this call has a level of software development experience in any language. Elixir is a programming language. Yes, like every other programming language. And as you know, in programming, we write software, we have to test our software. So the good thing about Elixir and testing is that Elixir, the primary tool for testing Elixir is called XUnit. Okay, if you're from a Java background, this is like the JUnit or something like the PHP unit or stuff like that. The XUnit is built-in, is a built-in framework in Elixir. So when you install an Elixir program, you have XUnit as part of it. So basically, Elixir treats testing as a first-class citizen. This is quite important because in some other programming language, you have to install a bunch of external libraries to do like basic testing, right? Yeah, but so it's a plus, exactly. And it's very easy to get started with. XUnit, right? So when you install Elixir, when you have Elixir installed, I was going to write a bunch of code. Sorry guys, I'm not so used to Google Meet as a tool. Okay, we'll come back to writing code. Let me just walk you through. So to start writing a test in Elixir, the very first thing you need is to start XUnit. And you start XUnit by simply calling XUnit.start function. That starts the entire test suite, okay? And basically, for what it is, an Elixir, a test in Elixir is basically a module that uses the XUnit case, right? So when you create a module in Elixir, and from what you're seeing on my screen, we have the def module macro to create a test called African test, and we use the XUnit case, and then we group our tests with the describe macro. Basically, the idea of grouping your test is you want to group all the test cases, for example, under if you're doing unit tests, under a single group. So you have a describe macro to describe your test, and you write your individual test. So the simple test on my screen basically is an assertion test. So I'm saying I'm creating an African test, and I'm going to test if Africa is not a country. And as dummy as my test looks like, it's always return true, right? So my test is always correct. Of course, Africa is not a country, so I would always get a correct case. Running your text in Elixir is very simple as well. So we save our text as Elixir script file. Basically, we save them as .exs files. For regular Elixir script, we save them as .ex files. And we run our text using an Elixir, the name of the file, Elixir name of the file to run the text. And the good thing is that it comes up with the result. You have the number of test cases, the number of failed cases, and and every other information that happens. So testing in Elixir is very simple. So you can just start your interactive environment, create a file, start the X unit, write your test cases, write your assertion, and run your test with a simple command. So that's how easy it is to test, to write tests in Elixir. Okay, so while we look into this a little bit, whenever we're writing software, we tend to test like where do you start testing? How do you start testing? There are a couple of approaches to that. But my preferred approach is to write test first. If I'm writing a project, right? So my approach is to write tests first. Okay, so I write tests. I follow the test during development approach. So I write my test cases and then write the behavior, the implementation of the code itself. It's easier because you have the, it enables you to plan. It's faster. You define your behavior. This is how I want my code to behave, and you force your code to behave that way. I mean, it's easy. Now think about if you're traveling from one location to another. You need a map, right? So you're saying if I get to like 10 kilometers, I should find a man wearing a red shirt. Then next kilometer, I should get a bridge. The third kilometer, I should say something else. So think about your test in that case. You need a direction. You need like a behavior that you need to. You need an expected behavior. So you define like a plan or like a test that if I move to this point and I don't find this, it means I'm on the wrong direction. If I move from point X to Z and I don't find this formation, it means I'm going in the wrong direction. So that's the way I look at TDD from TDD from my experience. So I like writing my test cases first, and then implementing the behavior of of the functions. Okay. So what makes a unit test? What makes a unit test what was a unit test? In my opinion, a unit test is like test a unit of behavior. Now think about test a unit of behavior, not a unit of code, a unit of behavior. So we can say that unit test, first of all, it should be like independent, right? It should be isolated. So we can define that unit test if it can run on its own. It actually does not depend on another module, an external behavior, or something else. It's just by itself. That's what makes the unit. It does not communicate to maybe like an external API or something else. It does. It carries out a particular behavior, right? It has to be fast. It has to be fast. It has to run like very fast to run. So how do you structure your text for most of it? The popular pattern to structure text, we're going to go to the code at the moment, is to follow the arrange, act, and assert pattern. Now, the arrange, act, and assert pattern means you have can I pull my ID up to take you guys through code? Let me see. Why don't we use Skype for this or something? The last time it was a Skype call. Okay, just a couple minutes. I want to. guys, I'm struggling to use my Chrome screen. Maybe I will get comments somewhere on how to switch this, but it's fine. So what the AA pattern says is that first of all, you have a section called array section where you bring your code or your system under test and it depends into some desired state, right? Okay, and the desired state. A desired state could be something like desired state is like, for example, you're writing a function that will sum two numbers. That will sum two numbers. I somehow lost my slides. Okay, yeah, okay, I think I'm good now. Share window. So, can you guys see my screen? Hello?
Yes.
Hello, can you see me? Okay. So, yep, this is a very untidy text case, but I wanted to just explain what I mean. So usually, the arrange, acts, and assert pattern means when you're writing your code, you first of all define your expected, more like your input and your expected behavior. So I have a simple function that adds two numbers, right? And I want these are the two input values, and this is the expected result. So here is my array block, right? And the next thing is that I also want the act. At this point, I'm actually calling the dependency. I'm calling the actual function that I need to talk to. So I have a calculator function that adds two numbers, and I pass the two parameters, and I should get a result. On the last part of it, I need to assert the behavior that my expected result is the same as the actual result that the function calculates. So here I'm verifying the outcome of my function. If I sum 10 and 30, and I expect to get 40, if I don't get 40, it means the behavior of my function is wrong. So this is a general approach where people write how people structure the unit test. Not just unit tests, but tests generally. For most of the time, we will have to change some of this, but then it goes this far. So when you're creating a mixed project, I was talking about how you start your Elixir, write Elixir functions. When you're creating your mixed project, when you create a mixed project, whether it's a Phoenix application or just a regular Elixir application, Mix already sets up your testing environment for you, so you don't have to do that. So your regular Mix project looks like this. It's also like coded, but I've written most of the code before now, so pardon me, maybe it's smoother like that to code. So you create your new Elixir project. It creates this test folder, and it creates a test file here, and test underscore helper file. So within this file is where this is where your XUnit gets started. So whenever you run like mixed test application, it starts your unit, your testing framework. So the conventional approach is to structure your text the way you structure your modules. So for example, when you have a module called calculator, and it's a dummy calculator for what it is, right? It basically takes two numbers and returns the sum of them. It takes two numbers and subtracts the second from the first. Okay, yeah. Let's assume this is a perfect this is the perfect calculator that we can ever build, and we have this calculator within this folder or directory, if you call it. We have your libraries. The convention is to have repeat the same folder structure and have your test with it. Now, if you don't do this, your code could still work, but yes, it's just an approach about that. Yes. I lost my slides. I need to go my slides. Okay. So the general approach to writing tests in Elixir, like I said, it's quite straightforward. You create your test functions. You create your test module, and the convention is to when I'm testing calculator, the calculator module, which is this. The convention is to name the test case, the test file, and prepend it with the test function as well. Would it test this last part of it, okay? And the next thing you need to do, you need to use XCase. We're going to come to XUnit properties because I'll talk about property-based testing going forward. So like I said initially, you group your tests. You group your test using a describe word. You try to just group tests together, like a bunch of tests that do similar functions. And here I'm trying to assert this test should be able to add two numbers. So if I give 10 and this, and I calculate, I should get an expected result, right? Then the same function should be able to add like two negative numbers. So if I get a negative number and a negative integer, it should always give me a negative value, right? So it means it should be less than 0. So I have this test. And you can run this test by simply the mixed test, right? So with this, you have quite a number of tests running. My property-based tests I was outputting, so we're going to get like some crazy results. Let me comment those out. So I don't give up my ID. Yep. So this was the part of the code that we got. Okay. So yes. So I have a couple of tests. So I have two property tests running. I will come to property test later. Then I have 6 tests, and I have 0 failures. So if let's mess one of these tests up, and let's say what we're expecting is 41, 43. We run this test. One of these tests should, or a couple of these tests should fail, or that particular use test case should fail. So, and this is a nice thing about Elixir test cases. It gives you some level of descriptive error messages on why your test failed. So you can see from my code, it tells me that my assertion failed, and the code I was trying to test is assert expected equals to actual. On the left, I expected to get 43. On the right, I got 40. And it points me to the exact location where that code base is here, and I could trace it and just fix the code. So if we reverse to our previous place and run our test as well, we would fix our test cases. XUnit gives you a lot of options. Sometimes you don't have to always write this array doc. So imagine if you're not going to write in real life applications, you're not going to write function that some two numbers, right? Nobody does that. Yeah, but of course, when we do meet up and write books, we use simple examples to get everybody along in that. For most of the time, when you write functions, you are going to write you're going to find a way to share code across your test cases, right? So Elixir provides a way of doing that. So usually when you write your approach, when you're using something like JUnit, you have this a setup stage, you have the act stage, the tear down stage, and all these 4 stages that you write your software. So we do that. Mix provide us with such a tool. So consider a situation where I have to rewrite my summation function. So I wrote this function like this. So not still different, but a different module, and I have to retell this module. But then I needed to use these values across all my test cases. So in the first instance, we had to repeat it everywhere, but I needed to share these values across my test cases, right? So Elixir provides a set of macro that allows you to do this. So you can set up your values, and you want the first to be 10, the next to be 13, and spread to this. And this actually returns a tuple. But then when you use this within your test cases, it returns a map again. So technically, you can make this a map, and everything's to work. Okay, right. So within my test cases, I can pass the context here as a value into any of my text. So instead of writing each of these tests, I can reuse each of these values. And this is very important when you're writing software. Imagine you're building a full-fledged soft system that has to do with, let's say, user registration, sign up and sign in, and you want to test if a user has a valid account, you want to test if a user is banned and all that. You want to create some preconditions, given that the user is logged in, given that that user is authorized, given that the user account has been verified, the user can place an order, the user can delete an order. So this kind of blocks are needed when you write actual test cases. So these are the values you define within the context block, and you can share them. Ideally, you have a setup block within a describe block, but Elixir also provides you with you can have a shared context that can be shared across. So you can have something like this, setup all. So there's a function, there's another one called setup all. Am I getting that right? You can have all your blocks here, and you can share them across your describe sections. Okay, so I want to jump to a different section. Pardon my initial skills. So another cool thing that XUnit provides for you to test is that Elixir treats documentation very, very good, right? Very important. So imagine after you've written your module or your library or your package, and you want a third-party developer to use this library. XUnit provides you a way to test your documentation. So if you're looking at my function here, I have what is referred to as a doc test. So I can document my function. So basically, I created this, and I'm saying this function can add two numbers, right? So giving this example could be if I call this function with these two variables, I should get 7. Okay. And XUnit allows you to test your documentation as well. So this line, this macro doc test, and the name of the module where these tests are located enables that. So if I run this function like I did before, you can see my doc tests were also tested. My 2 doc tests were tested. And it actually tells this code. For example, if 2 plus 3 plus 4 is 3 plus 4 is 7. So if I change this to like a different value, say 10, and I run this test suite all over again, I'm going to get I can mess up my code entirely. Sorry. But here is better now something. Where did I mess up my code? Oh, okay. Value function called summation this. This should be here. Good. Okay. Yeah, that's good. So I was actually calling a function that does not exist. So the name of the function is unit this is a good thing why I like this, so I can get my errors. So this is the name of the function. So I'm supposed to call this. It should be fine just now. So my text are working. So assuming I specify a different record instead of the expected record, my dog test should fail. Now, what this gives you as a developer or as what this kind of give confidence to yourself and as well as people using your library. Now, if the tests are passing, it means they can just read the documentation of your library and they can use the library with confidence, right? So that's one cool thing XUnit brings to the table. There are a couple of other things we're going to look at and those that we can cover on XUnit. But I would like to talk a little bit about another way of testing. Now, when you look at most of this code base, we have to test for most of the known cases, like edge cases. We have to test for like negative values, we have to test for positive values, then we have to test when a value is not created. So sometimes for a simple function, you have to write a lot of tests yourself. You're going to write so much tests that there's no something like writing too much tests, to be honest. But then what if we allow the library or the computer or the programming language to automate the test for us? Because test automation is what we should drive at. I was working on a project sometime last year that was heavily tested. Basically, we had a couple of layers of testing. We have like the IO layer, we have the service layer, then we had GraphQL on it, then we had REST APIs, then we had like some Phoenix templates as well. And by our convention, we have to test each of these layers. So we have to test the bottom layer, we have to test the integration layer, we have to test the UI, we have to test the front end, we have to test our GraphQL endpoint, we have to test our REST endpoint as well to ensure everything works. What if we can actually automate this test as much as possible? So this is where a tool like property-based testing comes very handy. So I'll talk about property-based testing in a short while, and let me see where I can switch our slides back to property-based testing. There. So hard to move around it. Yeah. Okay. Good. So another thing about your assert function is that Elixir allows you to write custom error messages. So if you want a custom error message on your assert function, you can define that as well, right? So let's talk a little bit about property-based testing. The truth is that for most of it, you won't be able to cover most of the edge cases when you're dealing with your tests. And that's where approaches like the property-based testing come handy when you write your test cases. Okay, so for what it is, let me explain the idea about property-based testing. You basically define some set of properties, like a block of code that your code base should satisfy, and you let the library generate a large chunk of data, some randomly generated data, and you use those data to validate those properties you define. That block of code you define. There are quite a number of libraries to do property-based testing. There is a PropL, is an Erlang-based library. There is a quick check, like that. There is a Elixir. And the cool thing is that the Elixir core team also developed one called stream data, which is something we're going to talk about right now. And XUnit itself adds some modules called external properties that you can use to handle some of these tests. So let's look at how a property-based test looks like. Now, this is a scenario of you're trying to like assert if this is straight from Elixir documentation. If you read the documentation, you're trying to assert that list should be the same. So given that I have a list of integers for a list of integers, right? So for every list, if I reverse the list, the length should still be the same. Okay. For every time I reverse this list, the length should still be the same. Now, the thing is that if you're going to write a bunch of example-based tests in our unit test for this, you're going to write a couple of test cases just to do this assertion. You're probably going to test for empty list case. You're going to test for maybe a sorted list and all of that. You're going to write at least 4, 5, 10 use cases. And even after that, you haven't been able to cover all that. Now, what project is does for you? Let's say that stream data provides you with a bunch of macros, like the check all, and it allows you to define a clause, a bunch of generators, and you, for every of that, you validate that against a property. So let's take a little bit of how, let's take a little bit on stream data and how it works. To get started with stream data, do I have to switch my slide all over again? I hate doing this. I was hoping for a live coding session, but okay. So stream data. So stream data is a library created by Elixir core team that lets you enable like property-based testing generally. So with stream data, it has functions. It's basically a generator that lets you generate random data and a bunch of macro that you can use to like iterate, write your test cases over this function. So think about stream data like it implements an enumerable interface. Think about it like it's a form of a lazy construct, right? Like stream, and it has functions to create things like integers. It has functions to create a list of values. It has functions to construct data however you want those data to be created. So on this example I'm about showing right now, takes let's go back to my IDE again. I would like communication. Am I communicating at all? Since I'm talking to myself. Can we get some feedback?
You are.
Okay. Good, thank you.
Maybe try sharing your entire screen.
My entire
sharing a specific window. Yeah.
Oh, that makes sense. I'm actually on a two large screens. So I wouldn't want you guys to see some of my nice pictures on my screen. So
just desktop one.
Can you find a way to do that, right? Share window. On Microsoft Teams, it allows you to like share a particular screen or something. These guys, how come Google makes such a crappy tool? Or I'm the guy that is crappy here. Share screen, share window, share your entire screen. Oh, okay. So bad. Yeah, I think we get our, but let's go through what stream data looks like, right? So stream data lets you, oh, like I'm still showing a particular window. Oh, okay. Let's see. I share my entire screen. Yep. Seem to get it right now. Okay. My entire screen works, right?
Yes.
Yeah, it works.
Okay, cool. So a stream data is like is a library that enables you to. I can't cover the whole of stream data within this program, but just check it out. If you're reading Elixir before, the documentation is so good that you can read most of the examples I'll show you. I'll be picking them from the documentation, right? So to use stream data, you need to include. Initially, it was supposed to be added as part of Elixir 1.7, but I think because of some API conflict, it was moved to, it was kept as a separate library. So you need to include stream data, you have to include stream data in your test, just like this, and you can set the environment that it should. Ideally, it's just for test environment, but I wanted to write some of this code on my terminal, and I wanted to be available in dev environment, something like that. Just a convenience for me. So if you're not good, if you don't want to use it outside the test environment, you can just get rid of this, right? So that's that. So this is all you need to start using automatic-based testing in Elixir. So the first thing is we're looking at our calculator function. Our calculator function, in the initial point, I was going to sum to test case. I was going to sum two numbers. Like I have to, first of all, arrange my code. I have to call the dependency. Then I have to assert this, right? And I need to test another use case. So maybe I have to test more cases. I need to keep testing more cases because as we always do now, we're going to cover every edge case of our behavior. So we have to write so many test cases. Now with property-based testing, you can make the library do that for you. So take a look at my first property. I'm saying I'm basically doing, I'm trying to sum like two numbers, right? So I said, give me a number between the range of 7 and 10 as the first number. The next one should be between 4 and 8. Can we sum this number? And always assert that this number is greater than, the sum is always greater than this, and the sum is greater than this. Of course, when we do summation of two numbers, they have to be greater than each other. So let's make this work with our test, which is this. So I'll pick this line of code, and I will replace this here. I'll replace this here, right? And I'll call this, I'll just say int1 and int2, all right? So I want to, yeah, let's see how sum is this. So when we run our test cases, where's my ID? Not bad. My IDs were messing up big time, so I had to speak about this in this. Something is going on. 7 and I got 10, okay? We didn't rectify this particular test, summation. So cool. You get this every time we write tests, right? So this is the essence where we actually write tests to make sure that our software works, right? So when your code, a developer or yourself change a section of the code, it breaks something, and if you don't test, you actually don't know if that part of the code is broken. So yeah, the part I wanted you guys to see on this is when I take a look at this test. In this case, I had to write a couple of tests to do this. But what the property-based test library is doing is that for this clause, for this bunch of, let's say, data I've generated, run this assertion for me. So with a single block of code, I'm able to like test huge scope, like without having to write much. So when I was talking about that, sometimes one of the purpose of us writing tests is not just to like write, it's to write fewer tests, right? With property-based testing, you can actually write fewer tests and cover more edge cases. It is not a direct replacement for like example-based testing. It's more like a complementary thing. Think about the edge cases that you cannot cover. Think about those corner cases that you can't really think about. So property-based testing comes to that for you. So at the bottom of property-based test code, you have a bunch of generators. So let me just take you to the library. So if you ever use Elixir enums or streams or what stream like that, this seems very familiar, right? So your stream data allows you, it gives you function to create and combine generators. So these functions are quite much in number. We're just going to look at a few of them and see what we can do with them. So you want to create a bunch of atoms. You can generate them with stream. You want to create a bunch of binaries. We want to do like binding. I will come to binding. It's kind of very important if you want to like create a couple of stuff. You want to create integers. You want to filter. So let me give you an example of something I was trying to do before this talk came in. So within my small program, I have a struct, and this struct is basically a user struct. Like I imagine my system has a user. I have to manage an account to have this user, and in my test cases, I want to generate data to test this user. Okay, so with stream data, I could use my bunch of generators, combine them, and create these cases. So let's look at how we can do that. Okay, I was writing a bunch of things. So ignore everything here. So my boilerplate code, blah blah blah, and all that. So let's get rid of this, for example. So looking at my profile, a user belongs to. I have a simple struct that says. I assume everybody knows what a struct is. So think about a struct like if you're doing Golang, think about your Go struct. What other language does that? In Rust or in it's basically what you use to like structure data in Elixir, right? So so a struct, I have a struct called a user called name, industry, and I probably want them to have an access code. And in my test case, I want to generate data based on this. So what I have here is I define an Elixir list of the kind of industry that I just want, like mine, tourism. And I want to use the stream member function, which you can find the details of it within your this. So basically what the stream member function does is it picks out like a member from this list that is generated, right? Particular range. So I have this, I have this, and I want to pick a member from this industry. Okay. Then I want to also generate a random user. I'm using an alphanumeric. I want an alphanumeric string, right? And I'm using stream data, generate string. Give me a minimum of length of 1. I just want the length to be about 1. And I also want an integer between these two range. So what I'm trying to achieve here is that I want to generate mock data. Think about, I just want to generate a list of users so much in number that I would want to test, maybe to test my user account or to test an identity system that I'm developing, right? So think about that. So with the generators, with the bunch of generators that stream data gives you, you can create a lot of this together. So first of all, I'm taking a bind function, the bind generator. So I'll pick this industry, right? And basically the bind takes, you take the signature, it takes a term, it takes a function, right? And it returns another term, right? So it takes this generator and this function and runs this function actually. Sorry for the break. I stay in an hotel here, so there's a room service just came, so you're fine. So with this, then I can call another generator called a map. So for each of these generator, which is for each of these mining, banking, tourism, I should apply this function. And basically what this function does, it runs this map as well. For each of this random string that this generates, I should do execute this. So basically I am setting like values for my struct, my user struct. So the end result is that I'm able to generate a bunch of, I could generate as much data as I want. So if I want to create test cases, if I want to create test cases, if I want to create test cases, I could generate as much data as well. This is just to show you how how you work. So let's look at there is a macro within within stream data that you can use to generate your test cases. It's called a gen all. So looking at this example of summation test of this, okay. So I want to generate my record, so I create my property, right, version 2, and I have this list, and I have this generator, and I have this macro called gen all, and it allows you to like take multi-clauses. So the first clause is that I want to get a list of industries for each of them, and the next case is that I need a stream data of length 1, give me a user, then I want code for each of these blocks. You can see it's a do block from here to here. I should do this. So let's see how this outputs. We can go through our terminal to run this code to see how this works. So when I generate this code, I have a bunch of users, right? So I have these users. So for each of them, it generates a new record for me. So I can do this, have this all of records that I want, and I can run test cases on each of them. For this particular case, I'm just inspecting because I really have no behavior to test. I didn't write any function to do this. So assuming I have an assert function that actually validates, let's say, assert, is a valid account or something like that. Okay. And I have the struct here. So this is kind of a use case that you have this. So you can test all edge cases, something like this. So as much as this seems a little bit not convenient, one thing you can take away from it is that as a developer, if you decide to write your example-based cases yourself, or you decide to write each line, like we all do, like everybody do with your software like this, you are not going to cover every edge cases because we're just limited to what we can do. So that's what property-based, that's the advantage, like property-based testing. That's an example of what the property-based testing brings to you. This meetup is not going to teach you property-based testing or testing as a whole. That's not my goal. My goal is to bring some of these tools to your awareness and to also make you embrace them and find the benefits in doing them. So it's a large library, but one thing I can tell you is that by the time you start reading through this, you get a bit of it. It's just like you're writing your regular Elixir program with generators, right? So we have I have this use case here. So I have so think about, let's just pick the examples. I hate typing. I don't know for you guys, but I hate typing. I like copying and pasting so much. So apologies for that if I'm doing that. So so let's pick something like, let me pick my examples. That will probably be easier for me. So I have an industry or something like this, and I have this. Sorry, I have this. Industry will always give me a string. Whenever the generator is always of type string data, right? Right, together. So, and they're lazy. So you have to like apply a terminal operation on that. So I can say this and do dot take and this. So I want maybe 3 out of it. I'll get 3. Okay. 1, I'll get 1, something like that. So you always have to apply take to get value out of it. But if you're writing a party-based test, your gen macro and your check all macro actually handles that part for you. So here I'm using, think about my generator. This is my generator that I've created. This has given me the values here, and I can use this by saying, basically I'm saying for each of these, take the value here. Okay, so that's how the stream data library works. There are a couple of other property-based library that you can take off of. There's proper check actually. So you can use this if you want. There's a quick checker, and there are quite a few, and it's cut across all programming languages, right? If you're using Java, there's a good API for that as well. If you're using other languages, everything comes out how it does it. So with property-based testing, it allows us to cover some corner cases, some cases that we really can't know about, and then we can also write fewer tests, and we can cover a lot of test cases. There are other things I would like to talk about. I think my slides are there. What integration tests are? Integration tests is basically that test that depends on every other component, right? We said unit testing itself is a test that tests just a component of behavior, a unit of behavior within your code base. If your test goes beyond that, it becomes an integration test. So think about when we write software, one good thing about functional programming is that we have this whole idea of writing pure functions, right? And if you're writing functional programming, be it's Haskell, or you're writing Scala, or you're writing Clojure, there is so much emphasis on writing pure functions. But the truth is that functions are not always pure, because they always have side effects. So you're going to write to database, you're going to maybe read from an external API, you're going to call a different function. But basically, for what it is, a pure function is a function that its output depends solely on its inputs and its internal algorithm. So it does not depend on something external, right? That's the base definition of what a pure function is in functional programming. So for most of what it is, pure functions are very easy to test. But when we write applications, we have to talk with database, we have to talk with external APIs, we have to talk to queues, we have to talk to other modules, we have to talk to other functions within our code base, right? And for most of that, we have to test across board. We have to test behaviors. We have to do a sort of integration test, right? So whenever your test cut across not just a unit of code, you have to deal with integration testing as well. Okay. There are other things. There are other forms of things you have to test within your application, which I probably wouldn't. I don't think I have much time to cover. We deal with things like a UI testing. So user interface testing. So there are a couple of libraries you can use to do UI testing in Elixir. So let me just give you one. Hound is a very popular one. Yes, that's the spelling. So when you do this, it allows you to write acceptance test and integration test, right? So imagine you have a web page that you're supposed to, when you click on a button, you're supposed to get a particular information. So this is the example book, right? If I visit this URL, example.guestbook, I should find an element with a name, an HTML element with a name message. I should fill a feed, right? That has this, that starts with happy birthday, for example. And if I should click on the submit element, I should get a response that says, thank you. Do you get it? So these are a couple of, there's sometimes from browser automation tests. There's another library called Wallaby. so much hate Wallaby. Sorry if you're one of the authors of Wallaby, but then it does the same thing for you. I had a code base that has a lot to do with Wallaby. So with Wallaby, you can also write a bunch of tests like that. So you start a session, you visit this link called to do. There's a text field called this. You write my first Wallaby test, and just like you click on the button. So in a way, when you write this kind of test, the whole idea is that you have to test all components of your application. You have to test your new units, your unit code. You have to do integration testing. You have to test your UI, because you can't leave everything on guesswork or just instinct, right? So you have to do a couple of these testing. So you can explore a lot of these tools within the Elixir ecosystem and find out what you can pick from them. There are a couple of tests, and I will share those when I'm doing my slide. I will share those links on the slide as well. So to round up, I'll probably just advise on some things you should do when you're writing tests. For what it is, always try to write tests first. I know most of us don't do that, right? We should always try to learn how to write tests, especially when we're writing software programs that we're going to ship to our customers. It's very important. You don't know the cost. When we're starting, we talked about AT&T losing $200 millions, and the NASA space program also losing millions of dollars just because of a line of code. So you don't want to do that. You don't want to start building a financial system and you end up adding zero to all your customers. So you end up paying them millions instead of thousands of dollars every time. So these are the kind of things that Testing check for us in our program. So for what it is, I want to encourage us to write tests first. I want to say, for most time, there are approaches, there are tools, there are patterns that have been discussed. Stick to what works for you. Stick to what works for you. Yes, some approaches are better than others. But most time, as a team, you have to define how you're going to write your test, like agree on a pattern, on approach. And another advice is that if you're going by test-driven design, never ship a code to production if the test cases are not passing. Okay. Of course, you're going to deal with flaky tests. You're going to deal with flaky tests. You're going to deal with some edge cases. You're going to deal with something, but it's always good to like run all test cases to see how some of those things work, right? Some other things is I was going to a couple of things I'll share. There are lots of books that deals with testing. Lots of books. There are not too much Elixir books that cover testing, but there are quite a number. A very good one is a book called Mastering Elixir. Mastering Elixir. Not this book. I'll try to find the book right. So there's a book called Mastering Elixir. Let me get my book like this. I could get you guys. Okay. So there's this book called Mastering Phoenix Framework. It's a nice book. I don't know if you guys can see that book. It's a series of books that covers Elixir and all that. So this is a nice book to read. This book covers like building an e-commerce website, and everything is like test-driven approach. So you write the test first and write it. It's a nice book to read. So if you have time, please look it up. There's a book on PactPub called Testing Elixir. Testing Elixir is another good book to read. Mastering Elixir has a section on that. Programming Phoenix has some section of testing as well. There is a book that centers so much on property-based testing. Most of the code there's a code base that's, sorry guys, I have so much. But here, testing, let's see, okay. Yeah, this one. So you have this book called Property-Based Testing. So this book deals with property-based testing. It's a nice book to read if you want to know so much about property-based testing and all that. So yeah, there are other books that are really not Elixir books that I enjoy reading when it comes to testing. One of them is Unit Testing. This book here is written in Java, but for what it is, you can really learn a lot about it when it comes to testing. Testing is a broad field. It's something you have to do all the time to master it. It's something you have to enforce as part of your team to do. It's something you have to learn to do. It's something you have to. It seems painful when you start with, but like, trust me, the end result is always good. So my takeaway for you for this meetup is that always test, keep testing, refactor and test. So test, write your test, write your behavior, and keep refactoring till you get a good result of it. So I'm going to take a pause, and I hope my few minutes of rambling, you pick something beneficial from it, and I will take comments and questions. Thank you guys for your time. Hello.
That was an awesome session. Could I ask a question about load testing? Like any recommendations? I saw you speak about stream data, so it sounded relevant.
Okay. Yeah. There's a particular tool I use for load testing. It's automated to record K8. I'm trying to get the URL out checked. That's what we use officially at work. Cases or something. Cases. And most time we use like to stress our endpoint for our microservices, just in case. Let me share this. Let me share the link. There could be a couple, but this is the tool I normally use because it's developer friendly. So you can hit your endpoint with a specific number of load, like, and all that, and see if your programs are crumbling in the face of load. Yeah. Did I answer your question? I'm not an expert on that too, but I use it a lot.
You did, though. You've given me something to research on.
Yes.
Thank you.
Okay. Hello, Shuaib.
Yeah, pretty.
That was a wonderful session. So my question was with stream data that you use in your test. So why did you prefer the stream data?
Oh, okay. Why prefer the stream data? Okay, the one I was using before was the prop air something. That level was really written in Erlang, and for what it is, I am not a huge fan of Erlang syntax. Okay, I'm from a Java background, so I'm used to nice locations. Okay? But why I prefer stream data, I'm just biased towards it, right? First of all, the API feels like regular Elixir API for me. So it's as if I'm writing strings and maps and was it just like any notebook, because the stream data basically, what do you call it? It implements the enumerable protocol. So it feels home to me. It's like writing regular Elixir code. Number two is that it is being maintained by the Elixir core team. So this is created by the guys who created the language. So what else do you need, man? So those are my bias towards it. But then, like, there are lots of tools out there. So look at what works best for you and your team and adopt it.
Okay, thank you.
Any more questions?
Hi, Shuaib. Thank you for your presentation. So my question is, what's your take on using test doubles in Elixir?
You know what?
What is your take on using test doubles, something like mocks, spies in Elixir?
Well, it's difference of opinion. But really, is it possible for us to actually write integration testing and all that without mocking data. Okay, there are lots of talk about that. There's a lot of arguments regarding that. But for what it is, sometimes you have to mock a lot of things. Elixir has a good library that allows you. I think it was written by Joseph Berlin. It's called mocks. Let me see. I think for most times, there are reasons why you have to mock API. So think about if I'm talking to a third-party application. For example, I'm integrating with Stripe or Checkout or any third-party application, and I have to keep hitting their APIs every time to test my endpoints or to do my integration testing. For what it is, I'm not helping them. I might, depend on their deployment, I might run their logs with data. I might, run their instances off if it's not properly deployed. And sometimes it can be time consuming for what it is. So in those cases, yes, you have to mock a lot of information. But then I also think that sometimes you're testing things like database, you actually need to, people mock database, like the in-memory database and all that. But for me, I prefer actually hitting the actual database, like to feel that experience. Okay. One good thing about Elixir or Phoenix is that when you create a Phoenix application, it creates like these sandboxes for you to run some of these tests. Okay. In some other languages, you have to, in some other frameworks, you have to create those things yourself. Yeah, we can't do without mocks, but we also have to test with actual data or actual endpoints. I don't know if that works for you.
Yeah, because the reason I was asking was if you look at XUnit, unlike let's say a framework like Minitest in Ruby, it doesn't come with the mocking functionality. Yeah, so maybe I thought since the developers didn't have it, maybe they felt like mocking wasn't something that important. But you've actually give me a reason why it's important.
Yeah. I shared one library called Mox. I think it was written by Joseph Berlin himself. I just on the chat.
Okay, cool. Let me check it out.
There's another one called what's the name? I don't forget. But for most of it, I think with string bit, there's one called okay. I think for most of the library you will need for Elixir, there is a list on GitHub called Awesome Elixir. Basically, for any language, if you go look for Awesome Java, Awesome JavaScript, you're going to get that whole list. So let me share one here. So when you go through that list, you'll find a lot of libraries and tools and HTTP, screencasts, and everything that you want to do with. Okay. So yeah, you're going to see a lot of examples on mocking data and so many things. Right. So I'm going to share the links on the slide as well and the books and everything. You have more content?
Okay, thanks, man.
Yeah. So thank you guys for your time. I really appreciate your presence, and it also was a learning experience to write prepare for this presentation. I hope you guys enjoyed it. Thank you, ElixirKenya, for your regular meetup. I'm a huge fan. It's like this is your 1-0 over Nigeria. It's like we don't do this in Nigeria, so yeah, it's a good one. So keep it up, guys.
Yeah, thank you, Shuaib. And yes, we enjoyed it. Thank you for an enlightening and entertaining session on testing Elixir applications. We appreciate having this mysterious area clarified. The session has been quite memorable. The audience may not know this, but we owe you a special vote of thanks for being here. We appreciate you taking your time and energy to grace this event. Once again, thank you.
Thank you, everybody. Thank you, guys. Bye.
Thank you, everyone. Bye-bye.
Bye.
Bye-bye.
Bye.
Tracy can stop the recording.